Welcome to Sham Bites English YouTube channel.
Today we are going to see a short video about Burj Khalifa. Before entering into the topic, please subscribe the channel for more videos. Dubai experienced tremendous growth and financial success during the late 20th and early 21st centuries, evolving from a small trading port to the business and tourism capital of the Middle East's Gulf region. At the height of the city's economic explosion, Dubai-based real estate developer Emaar Properties PJSC envisioned a super-tall tower that would become the centerpiece of the new downtown Dubai. In 2003, as part of a competition, Emaar hired Skidmore, Owings, Merrill, SOM, to design what would become the world's tallest building, the Burj Khalifa. The construction of the tower began in January 2004, with its official opening occurring on January 4, 2010. Today, the tower tops all three categories designated by the Council on Tall Buildings and Urban Habitat as defining the tallest building in the world, eclipsing the previous height record holder by 319 meters. Apart from being the tallest building in the world, the master plan for Burj Khalifa responds to the global movement toward compact, livable urban areas. Downtown Dubai sought to create a new city center, addressing issues of trade, transport, tourism, industry, and finance in response to the city's economic boom. The Burj Khalifa stands in the center of this new downtown community, spurring surrounding development and operating in similar fashion to a small vertical city. The project consists of the super-tall tower with an integrated podium structure and an ancillary 12-story office building and 4-story pool annex, which complement the tower at its base and define plaza spaces on the ground. At ground level, the Y-shaped plan allows for each use to have its own distinct entry, with paving, landscaping, and fountains to create an individual experience. The tower's mixed-use program, consisting of hotel, residential, and office space, responds to the area's development density and provides residents, guests, and visitors with direct connections to adjacent site amenities, shopping, and mass transit systems. Architecture, standing tall at 828 meters, Burj Khalifa meant pushing current analyses, materials, and construction technologies literally to new heights. However, as such a building height had never before been attempted. It was necessary to ensure all technologies and methods used were of sound development and practice. The designers, therefore, employed conventional systems, materials, and construction methods, modifying and executing them in unprecedented capacities. The building's Y-shaped plan was employed not only to develop an inherently stable geometry for the structure but also to yield the maximum amount of perimeter. This gave accessibility to views and daylight, without allowing tenants to look into neighboring units, which would be culturally unacceptable. As the tapering tower rises, setbacks occur at the ends of each wing, in an upward, spiraling pattern that decreases the mass of the tower as the height increases. The spiraling is reminiscent of spiraling characteristics seen on ancient Arabic obelisks and monuments. During its developments, this setback structure was modeled in a wind tunnel in order to determine the safest and most effective way to minimize wind forces, and was the result of close coordination between architects and structural engineers. Exterior cladding is comprised of aluminum and textured stainless steel spandrel panels, and was designed to withstand Dubai's extreme environment. During the summer months, vertical polished stainless steel fins were added to accentuate Burj Khalifa's height and slenderness, providing some shading on the exterior surface and catching the light at the beginning and end of the day to enhance the spectacular quality of the tower. With over 3 million square feet of interior space to be designed for Burj Khalifa, planning of the building's interiors began at the earliest stages of its design. The design team worked towards attaining three main goals: recognizing and acknowledging the building's height, integrating its structural and architectural rationale, and appreciating the locale's heritage, history, and culture. Structure. The unprecedented height of the Burj Khalifa required it to be the most innovatively engineered building possible. Design techniques, building systems, and construction practices all required rethinking, redefining, and, in many cases, reinventing applications already in place to create a practical and efficient building. Created especially for Burj Khalifa, the structural system consists of a six-sided high-performance reinforced, concrete central core with 3 wings. A system also, dubbed a buttressed core. Loads from one wing are transferred to the other wings via the six-sided core. Corridor walls extend from the central core to near the end of each wing, terminating in thickened hammerhead walls. Perimeter columns and flat plate floor construction complete the system. Outrigger walls tie the vertical structure at the mechanical floors in order to maximize the stiffness and stability of the building. The result is an extremely efficient structure, in which the entire vertical structure of the building is used to support both gravity and lateral loads. Shaping and orientation of the tower were significantly influenced by its performance with respect to the strong winds. Numerous wind tunnel tests and design iterations were needed in order to develop solutions for optimal performance. Constructing the tower necessitated the highest single-stage pumping of concrete ever performed, an awe-inspiring 606 meters. An approximately 230-meter tall structural steel spire tops the tower. Sustainability: the Burj Khalifa implemented new ways to increase structural and construction efficiencies while reducing material use and waste. Lessons learned from Burj Khalifa will help future super-tall projects reduce the environmental impact associated with construction and raw material extraction. Sustainable elements of the Burj Khalifa include sky-sourced ventilation, cooler air temperatures, decreased air density, and reduced relative humidity at the top of the building allow for sky-sourced, fresh air. When air is drawn in at the top of the building, it requires less energy for air conditioning, ventilation, and dehumidification. Condensate recovery system: Burj Khalifa has one of the largest condensate recovery systems in the world. By collecting water from air conditioning, condensate discharge is prevented from entering the wastewater stream and the need for municipal potable water is reduced. High-performance glazing: a low-emissivity glass provides Burj Khalifa with enhanced thermal insulation against the high ambient temperatures of Dubai. High-voltage distribution conduction of electric power using higher voltages reduces energy losses and increases energy efficiency when compared to lower voltage systems. Electronic metering: individual electric energy monitoring systems enable energy optimization of the tower's systems over its lifetime. This will result in a reduction of Burj Khalifa's energy-related environmental impact. Smart lighting and mechanical controls: the building's management system results in lower operational costs, a more efficient use of building resources and services, better control of internal comfort conditions, and effective monitoring and targeting of energy consumption. Stack effect controls thermal differences between the building's interior and exterior generate a stack effect. Burj Khalifa was designed to passively control these forces, reducing the need for mechanical means of pressurization while saving energy. Conclusion: the design of the tower required intense efforts of collaboration between architect and engineer. Although height was central to the project's development, Burj Khalifa represents a progressive shift in design and engineering that presents new solutions to complex problems. By combining cutting-edge technologies and regional cultural inspirations, SOM created a vertical city that has become a model for the development of future urban centers and speaks to an ever-growing global movement toward compact, livable urban areas. Burj Khalifa represents significant achievements of a new, global generation of architects and engineers, and serves as a catalyst for the future growth and development of downtown Dubai.
That's the end. Thanks for watching the full video. Hope you love this video. We will upload video regularly, so don't forget to subscribe the channel. Signing off from Sham Bites.